Okay, so I'm going to go over problem 3 of the free response section of the 2023 AP Calculus A, B, and BC exam. And just so you know, they haven't released any of the official solutions, and they probably won't until like June or July. So if you think my answer has a mistake, or maybe is a little questionable, just let me know in the comments. Try not to be not to be mean about it, because I'm kind of sensitive and stuff. So, but anyways, I'm pretty confident in my solution. So here we go. So here we have a bottle of milk. It's taken out of a refrigerator and placed in a pan of hot water to be warmed. Interesting. All right, the increasing function M models the temperature of the milk at time t, where M of t is measured in degrees Celsius, and t is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm over dt equals 1/4 times 40 minus m. At time t equals 0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Part A. A slope field for the differential equation dm dt is equal to 1/4 times 40 minus m is shown here. Sketch the solution curves through the point 0.05. Okay, so this is pretty elementary. All you gotta do is, start from here and use these slopes to kind of guide what your line is going to look like. And it's going to be something like this, It's going to approach this horizontal line kind of like asymptotically. So I probably let's actually not make it cross in case they're really strict about that. It's probably going to stay on, make it clear that it's going to stay below. That's pretty much it. That's all you got to do there. Yeah. Not much more to it. Part B. Use the line tangent to the graph of m at t equals 0 to approximate m of 2, the temperature of the milk at time t equals 2 minutes. Okay, so what this is saying is that we're going to find the rate of change at t equals 0 and use that rate of change to estimate what happens 2 minutes later. So this is the rate of change at, this is the rate of change we're given. And let's figure out what the actual value of the rate of change would be when you plug in 0 for t. So let's go ahead, let's just do that. So where should I draw this or write this? I'm going to squeeze it in here because this page is not really much space. So dm dt, and again, this is when t is 0, and we're told when t is 0, m is 5. So m is 5. And so we have these values for t and m into this equation, 1/4 times 40 minus 5. So 1/4 times 35, which is going to be, 35 over 4, which is going to be, let's just leave it at 35 over 4. I don't want to mess up with a decimal approximation. Now, from this 35 over 4, we're going to estimate what's going to happen 2 minutes later by increasing the value of m by this amount twice. So m of 2, or again, your y value when t is 2 is equal to your y. This is essentially like your slope or your y-intercept. So 5 plus your slope, which is going to be this, times t, or 2. So again, just think of this as y equals, this is putting your y-intercept first, y equals b plus mx. It's just a linear equation. And then this, we just use our, we just kind of round this. That'll be 270 over 4. So 35 over 2, so 17.5. So 5 plus 17.5. and we would get 22.5. So the temperature of the milk would be about 22.5 degrees Celsius at time t equals 2 minutes. I was just able to squeeze it in there. All right, part C. Write an expression for the second derivative of m with respect to t in terms of n. Use the second derivative to determine whether the approximation from part B is an underestimate or an overestimate for the actual value of m of 2. Give a reason for your answer. Okay, so let's find what the second derivative would be. So I'm going to write that over here in this spot. Now you always do part D on a different page. So the second derivative is differentiating this and just kind of making this a little easier to work with. This is the same as 10 minus 1/4 m. So the second derivative of m with respect to t this constant just goes away, and then we just have negative 1/4 times dm dt. And then we kind of plug this whole thing back into here, which is kind of interesting. It's kind of weird to think about, but that's what it is. And then that's just negative negative 1/6, so negative 1/4 times this whole thing, or negative 1/4 times this whole thing. Again, I'm gonna try to fit it in neatly so you can see what's going on. Negative 1/4 times 10 minus 1/4 gives us negative 1, or gives us negative 10/4 or 2.5 plus 1/16 m. Now, so is this an overestimate or an underestimate for m of 2? Well, we essentially want to understand if this is going to be a negative value or a positive value. If it's a negative value, then we know the graph is going to be concave down. If it's positive, it's going to be concave up. Up, down. Now, this is going to be negative because when you plug in 2 for m, you'll get negative 2.5 plus 2/16, which is going to be negative. So then that means the graph is going to be concave down. And then that means that if we were using a tangent line, again, at a point before this, to estimate, maybe some point here, maybe that's like when t is 2, the tangent line is going to overestimate it because its estimation is going to be above the real value because the graph is concave down. And again, you can kind of just think about this. If you were to do a tangent line off of this point, you can see how it's going downward. This concavity is negative. And if you were to do that, don't draw this on your test. I'm just drawing it because to kind of give you a clear idea. A tangent line off of this point, would be above all the future points of this line. So I would put that it would be an overestimate because the second derivative of m of t, or in this case, well, when t is 2, is negative. Okay, now part D, use separation of variables to find an expression for m of t. The particular solution to the differential equation dm dt, which is 1/4 times 40 minus m with initial condition m of 0 equals 5. All right, so this one should be actually fun because you'll feel confident with this as long as you practice a lot with your separation of variables, because it's pretty step by step. Let's separate the m's, bring the m's to the left and the dt to the right. So dividing both sides by, well, let me write this more properly. Dividing by 40 minus m as a group, so 1 over 40 minus m dm equals 1/4 times dt. Going from there, integrating this, we'll get the natural log. The natural log of the absolute value of 40 minus m, except since we have negative m here, make your absolute log negative. And the right side is simply 1/4 t plus some constant, so I'm just going to call it c1. And again, if you're like a little like uncertain if your natural log should be positive or negative, just take the derivative of this, and you'll see that you'll get a -1 times 1 over 40 minus m, so the negatives will cancel, and you can be confident that's correct. All right, and so from here, let's just switch the sign because I hate having a negative mess around in my problem there. So -1/4 t. And I'm just going to call that c1. I'm just going to call it c2 because it's still some other constant. And then I'm going to take e as the base and raise it to this. So I'm then going to have e raised to this whole expression, e to the -1/4 t plus c2 is equal to 40 minus m. I'm going to move that out of the way because it's so uncomfortable. And so now I'm just solving this for m. This can be rewritten as e to the -1/4 t times e to the c2 is equal to 40 minus m. And e to the c2, e to some number is just some other constant. I'm just going to call it a. And I'm just going to put it in the front. So a times e to the -1/4 t is equal to 40 minus m. And I'm given the initial condition that m of 0 is 5, so 0, 5 essentially. So when t is 0, m is going to be 5. So then I can use that info to solve for a. E to the 0, that just becomes 1. And then so my a just becomes 35. With my a being 35, I can rewrite this as 35 e to the -1/4 t. And let me just bring that 40 to the other side, or I can just add this or subtract that or reverse it, doesn't matter. I mean, I think you can do this part without me having to worry about explaining it. And my pencil keeps on breaking. This isn't bad luck. Okay, anyways, here we go. So then, yeah, so then negative m, and then switch it 40 minus 35 equals m. M of t equals 40 minus 35 e to the -1/4 t. That should be your acceptable answer. All right, so there we go. So I hope you got that right. And if not, let me know if you have any questions. I can clear it up. But on to the next one.